differentiation of sine and cosine functions. Now, differentiation and integration, so calculus, for trig functions is done in radians. So if you're given a question in degrees, convert to radians first. Keep your calculator in radians mode. Now, this is a very useful diagram. It tells you that if you differentiate a positive sine function, you'll get a positive cosine function. And if you differentiate cos, you'll get minus sine. If you differentiate like a minus sine function, you'll get a minus cos function. So in its simplest form, if I differentiate sine, so I'm up here, I will get cos x. If I differentiate minus sine, so if I'm here, so if I'm differentiating a minus sine function, I will get minus cos. And if I differentiate cos x, I will get minus sine x. And if I differentiate minus cos, I get sine. So if that was minus, that would be sine. Now that's okay, but what about if the angle wasn't x? What about if it was something like 5x? A linear function, angle. Then we can use this formula. If you differentiate sine kx, then differentiating sine gives you cos. It's the same angle. You had kx, you've got the same angle on this side, but the k, the coefficient of your angle, you multiply by it. So if we're differentiating sine 5x, my diagram tells me I'm going to get cosine. The angle is always the same here. Now I have to take the number in front of the x, in this coefficient, I have to multiply by it. But what if your angle was not a linear function? Let's say if the angle was x squared, then you can't use this formula. This is only for a linear function for your angle. This is the one that you want to memorize. It's saying you can have the sine of any function of x you like. So the angle here, it could be 2x or 3x squared, it could be absolutely any function of x. And it's saying, well, differentiate sine to give cos. The angle here and here is exactly the same, so whatever you see there, you copy it. But then you take the angle by itself, differentiate it, and you multiply by it, like this. So if I'm differentiating sine, I know I'm going to get a cosine function. The angle remains the same, f of x, there it goes, f of x, so it's 5x in this case. And now I need to differentiate my angle. This is my f of x in the formula. If you differentiate 5x, you get 5. We need to multiply by 5. So we get 5 cos 5x. If we differentiate sine 3x squared, well, we're going to get cosine first. The angle, the f of x, remains the same on this side, so it's still 3x squared. And then I differentiate 3x squared, that will give me 6x. I need to multiply by that. There we go. So if you differentiate sine 3x squared, you get 6x times cos 3x squared. Okay, so memorize both of these. So differentiating sine, differentiating cos for an angle that's any function of x. And that's a very, very useful diagram. This diagram, going clockwise, is for differentiation. If you go anti-clockwise, it's for integration. So if you integrate cos, you get sine. But more of that later. Example 1. dy by dx. Using the diagram, differentiate sine to get cos. And when we're differentiating, remember sine will give us cos. Same angle. Differentiate the angle, you get 2. But we were multiplying with that 5. So we've got to multiply with that 5. That gives us 10 cos 2x. Part B, we're told that there's a stationary point in this interval, and everything's in radians. So for stationary points, dy by dx, the gradient on the graph will be 0. So I need to solve my derivative, my gradient, equals 0. There's a little issue here. The angle is 2x, the angle in the interval is x. So I need to leave this one alone and multiply all of these by 2. Worked out the coordinates for this point on the curve, and it's a maximum point, even though we didn't have to state whether it's maximum or minimum. The objective in the question was just work out the coordinates for the stationary point, and you didn't have to do a graph either. Example 2, we're differentiating cosine, and it's a positive function there, so we're going to get minus sine something, and it will be the same angle. And then we differentiate the angle, which will give us 10x. We need to multiply by that. So we have this. Example 3, differentiating minus cos, which takes us from here to here. So we're going to get sine, positive sine. Same angle. Now we differentiate the angle and we multiply by it. Now pi is a constant. If you differentiate a constant, you get nothing. If you differentiate minus 4x, you get minus 4. We multiply by the minus 4. Now we want the equation of the tangent at the point where x equals 1/8 pi. So the gradient, dy by dx, the gradient here, dy by dx, is minus 4. It's minus 4 times sine, open brackets, pi minus, there, pi minus. Now the angle is 1/8 pi, so you've got the minus 4, then instead of the x though, we've got to substitute in 1/8 pi, put it into your calculator in radians mode, and then the equation of a straight line, which is in the form y minus y1 equals mx minus x1. We have the gradient, so the gradient here, simplified from the calculator, was minus 4, that goes here. The x coordinate's already given. The y coordinate comes from the equation of the actual curve, this, which is 0. Substitute everything in, simplify, and we have the equation of the tangent. Graphically, we have our curve, which is this, and then we've just worked out the equation of the tangent to the curve at this point. If you look at the scale, that's a half pi. This will be a quarter pi. This is 1/8 pi, and the y coordinate here is 0, which is what we found out. So the tangent to that point on the curve is what we've worked out. Okay, example 4. This is given as x is equal to. So when we differentiate, we get dx by dy, not this. We can work out dy by dx at the end by just flipping things over, but for the time being, let's work with dx by dy. Okay, so we have a positive cosine function, so we're here. Again, going clockwise like we do, we'll get a minus sine function, so we'll have minus sine, same angle, 5y. I'll multiply by the 4 at the end, so I know that's still in there, we'll do that at the end. If we differentiate the angle, differentiate 5y, you get 5. I need to multiply by that. I also need to multiply by the 4, so now we have this. Okay, flip both sides over, so the reciprocal on both sides. So now we have dy by dx, which we can further simplify if we want to, because you've got the minus 1/20th here. Now 1 over sine is cosec. There we go, cosec. Same angle, 5y, 5y. Okay, example 5, I've got function notation. So f dash t is equal to, so we've got individual terms, so we differentiate them all using various rules of differentiation. So sine, that's a positive sine term, starting here going clockwise gives us positive cosine, so I'm going to get a cosine term here, and I'm going to multiply by 2. If I differentiate the angle, I get 3, so that's the first term done. Differentiating t squared, differentiating a constant gives us 0, so this will just be 6. For practice, try these questions. You might want to start from question 4 straight away. If you need more practice, start from questions 2 and 3.